Good afternoon, students. In the last class, we discussed about the impulse, right? So today we have impulse, momentum theorem, right? So what it states means impulse is equals to change in momentum. So already we know impulse and also momentum. So what is impulse? Impulse is large force acting on a short interval of time. So that one we call as impulse. So momentum, it is a product of mass and velocity. So that one we call as momentum. So change in momentum means there is a difference in two moments. So that one we call as change in moment. So this change in moment is equals to impulse, right? So consider one example, right? So one object having mass moving with some velocity. So initially we taken the u, that means initial velocity, right? So object having mass and it has velocity. So hence this object having the momentum, so that momentum we taken as p1. So initially object is moving with certain velocity. So any object which is moving means, so that object having moment, right? So that moment or linear moment, right? So that moment we taken as p1, right? So now while the object is moving, we are applying some force for a short interval of time. That means we push that object with some force for a short interval of time, that is t. So that gives what? The impulse. So we are applying the force for a very short interval of time. So this combination we call that one as the impulse. So next, what happens to this moving object when we apply the force? The object while moving, it changes its velocity. That means it gains some velocity and it starts to move with different velocity. So that velocity will be taken as v, right? So again the velocity changes. So here u and it changes to v. So again the object having mass and it has some velocity. That the velocity is different from the initial velocity. So here also there is a momentum. We note that one as p, right? So here change in momentum, that means difference, final moment minus initial moment, we call this one as change in momentum, right? Or linear momentum. So in simply we call that one as momentum. So difference na navenanta kariತೀವಿ change, right? So this change in momentum is equals to what? Impulse. So impulse means force into time, right? So we need to prove this one. So that gives what? The statement of impulse momentum theorem. That means impulse is equals to change in momentum, right? So any moving object having its initial has some momentum, when we apply the impulse, that means larger force in a short interval of time, we call this one as the impulse. Then the object changes its velocity. That means it moves with some increase in velocity or it moves with some decrease in velocity. That means the velocity changes, right? So velocity changes means again the object having the mass and velocity, again this object having the momentum, right? So the change in momentum is equals to impulse. So we need to prove mathematically. Then only the statement is valid, right? So this is just for understanding purpose and explaining by using the diagram, right? So from to prove mathematically, from Newton second Newton's second law of motion, force is equals to rate of change of momentum, right? So force is directly proportional to rate of change of momentum. So here the proportionality constant is 1, then we get F is equals to dp by dt, right? So now rearranging this, f into dt. That means cross multiplying dt to the LHS, we get f into dt, that is equals to dp. Calling this one as equation 1. Right? So now at time t is equals to 0. Right? So we are considering this one as initial case. So when time t is equals to 0, its momentum is what? P1. Right? So at t is equals to 0, momentum p is equals to P1. That means m into u. We can write that also. Right? So next, after some time t, right, we are applying the force for a short time, right? So that we taken t. Now the object changes its velocity from v to u, then we get the momentum p2. That means momentum changes from p to p2, right? Now integrating equation 1, right? So why we are going to integrate means we are finding the impulse, that means applied force from time 0 to t, right? So I am applying the time up to for 5 seconds. That means I am applying the force up to 5 seconds means how much the impulse we are applied to that object we are finding, right? So that's why we are integrating the first equation, right? So integrating here 0 to t. So these we call as limits. So 0 to t is the limits of the time from 0 to some particular time. We call that one as t, right? So keeping f dt, right? That is equals to, in the RHS, the moment changes from P1 to P2. So lower limit becomes P1 and upper limit becomes P2. So moment ಎಲ್ಲಿಂದ ಎಲ್ಲಿಗೆ change ಆಗಿದ್ರೆ from P1 to P2, right? That is dp. So ಇದು integration symbol. So this is the definite integrals. Definite means we have a particular definite values, right? Now here we are applying a constant force, so hence f is constant, we can take outside, right? So we are going to integrate only the time dt, right? That is equals to p1 p2 into dp. So integrating dt we get, so ಇಲ್ಲಿ ನಮಗೆ ಏನು ಇಲ್ಲ ಅಂದ್ರೆ, so there is some value, that is 1 into dt. 1 is a constant, so if we integrate a constant we get the time, right? So f t, applying the limits 0 to t. So here also 1 into dp, so we are integrating with respect to momentum, so we get p here. So limit p1 to p2, we call this as limit, right? So now f into t minus 0, upper limit minus lower limit, right? That is equals to place p2 minus p1, that is upper limit minus lower limit, right? So t minus 0, that is t, f into t, that is equals to p2 minus p1, right? So force into time, we call this one as impulse, that is equals to, where p2 is the final momentum, p1 is the initial momentum. So final momentum minus initial momentum, we call this one as change in momentum. So this we prove mathematically, right? So ನಿಮಗೆ integration maths ಅಲ್ಲನೇ ಅರ್ಥ ಆಗೋದು. So just here integrate the constant, we get the term. So t with respect to t integrate ಮಾಡ್ತಾ ಇದ್ರೆ t ಸಿಗುತ್ತೆ, with respect to p integrate ಮಾಡಿದ್ರೆ p ಸಿಗುತ್ತೆ, with respect to f integrate ಮಾಡಿದ್ರೆ f ಸಿಗುತ್ತೆ, right? So same constant if we differentiate, right? So constant ನ differentiate ಮಾಡಿದ್ರೆ 0 ಆಗುತ್ತೆ. So 0 ನ integrate ಮಾಡಿದ್ರೆ ನಮಗೆ constant ಬರುತ್ತೆ, right? So that is inverse, right? So this is about the impulse momentum theory, right? Theorem, right? So impulse is equals to change in momentum. So here P1 is initial momentum and P2 is final momentum. So change in momentum means final minus initial, we call that one as change, right? So same, the statement we start from the Newton's second law of motion, F is equals to dp by dt, or F is directly proportional to dp by dt, right? So ಇದು important, ಇದು ನಮಗೆ ಗೊತ್ತಿರಬೇಕು. Impulse is always equals to change in momentum, right? So the next, Newton's third law of motion. So the statement is, to every action there is always an equal and opposite reaction. So you high school alle study ಮಾಡಿರ್ತೀರಾ, right? So Newton's third law of motion, to every action there is always an equal and opposite reaction, right? So this is the statement for the Newton's third law of motion, right? So consider one example, right? So consider one ball or football. When this football is kicked by a player, or kicked by the leg or kicked by foot, right? The force which is exerted by the foot onto the ball, right? So force enagtide from the leg to the ball, right? So this force we call as action, right? So due to this action the ball moves forward, right? So in the same time ball exerts the force, that is the same force which is onto the leg of the player, then the leg moves backward. So this we call as reaction. So if the action is in forward direction, then reaction is opposite to that of the action, right? So on football kick ಮಾಡಿದ್ರೆ ball ಏನಾಗುತ್ತೆ ಮುಂದೆ move ಆಗುತ್ತೆ. So in the same time our leg will comes backward direction. So this is from the Newton's third law of motion. That means now leg ಇಂದ ಎಷ್ಟು force ball ಮೇಲೆ act ಮಾಡ್ತೀವೋ, in the same time the ball will exert the same force onto the ball. So ನಮ್ಮ leg ಇಂದ ball ಮೇಲೆ ಎಷ್ಟು force act ಆಗ್ತಾ ಇದೆ, so the same force is acting on the leg by the ball. So ball in the leg ಮೇಲೆ ಕೂಡ same force act ಆಗ್ತಿದೆ. For example, if I am applying 10 Newton force to kick this ball, means the same 10 Newton force is acting on this leg by the ball. So that means the force act ಆಗ್ತಿದೆ ಅಂದ್ರೆ leg ಕೂಡ ಏನಾಗಬೇಕು, ಮೂವ್ ಆಗಬೇಕು, right? So force opposite direction ಅಲ್ಲಿ act ಆಗ್ತಿರೋದ್ರಿಂದ leg ಕೂಡ ಏನಾಗುತ್ತೆ ನಮಗೆ opposite direction to the direction of the ball moving. So ಈ direction ಅಲ್ಲಿ ball ಮೂವ್ ಆಗ್ತಾ ಇದ್ರೆ leg ಕೂಡ ಏನಾಗುತ್ತೆ opposite direction ಅಲ್ಲಿ ಮೂವ್ ಆಗುತ್ತೆ. So action and reaction are the two pair of the forces which act on two different bodies when they are interact, right? So action ball ಮೇಲೆ ಆಗ್ತಾ ಇದ್ರೆ reaction leg ಮೇಲೆ ಆಗ್ತಿದೆ. That means two different objects or two different bodies, action and reaction will take place when these two are interacting with each other. So ಎರಡು interact ಆಗಿದಾಗ ಮಾತ್ರ ನಮಗೆ action ಮತ್ತೆ reaction ಸಿಗುತ್ತೆ, right? So ಇಲ್ಲಿ observe ಮಾಡಿರಬಹುದು, when we kick with the force the ball moves forward, right? So it is moving forward means it has some acceleration, right? So that means acceleration of football is more than the foot of the player, right? So force ಏನಿದೆ ನಮಗೆ ಸೇಮ್ ಇದೆ, ಬಾಲ್ ಏನಾಗ್ತಿದೆ ಆಕ್ಸಲರೇಟ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ತುಂಬಾ ದೂರ ಹೋಗ್ತಿದೆ ನಥಿಂಗ್ ಬಟ್ ಇಟ್ ಹ್ಯಾಸ್ ಸಮ್ ಆಕ್ಸಲರೇಷನ್, ಇಟ್ ಕವರ್ಸ್ ದ ಲಾರ್ಜರ್ ಡಿಸ್ಟೆನ್ಸ್. ಸೊ ಲಾರ್ಜರ್ ಡಿಸ್ಟೆನ್ಸ್ ಕವರ್ ಆಗಿದೆ ಅಂದ್ರೆ ಇಟ್ ಈಸ್ accelerated, right? So our leg will not cover that much of the larger distance. That means acceleration is very less for the foot of the player. So ಎರಡು ಕಡೆ ಫೋರ್ಸ್ ಸೇಮ್ ಇದ್ದಾಗ acceleration ವೇರಿ ಆಗ್ತಾ ಇದೆ. Why? Because again from the Newton's second law of motion, F is equals to m into a. So this is the relation we get it from the Newton's second law of motion, where F is the force, m is the mass, and a is the acceleration. So here we are discussing about the acceleration, right? So a is equals to F divided by m. So ಇಲ್ಲಿ ನಾವು ಅಪ್ಲೈ ಮಾಡ್ತಿರೋ ಫೋರ್ಸ್ ಏನಿದೆ ಎರಡು ಆಬ್ಜೆಕ್ಟ್ ಮೇಲೆ ಸೇಮ್ ಇದೆ. ಸೊ ಲೆಗ್ ಇಂದ ಬಾಲ್ ಮೇಲೆ ಏನ್ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ, ಬಾಲ್ ಇಂದ ಲೆಗ್ ಕೂಡ ಸೇಮ್ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತಿದೆ. ದಟ್ ಮೀನ್ಸ್ ದಿಸ್ F is constant, right? So F is constant, then acceleration is inversely proportional with the mass, right? So mass of the ball is less compared to that of the mass of the player, right? So mass of the ball ಏನಿರುತ್ತೆ ತುಂಬಾ ಕಮ್ಮಿ ಇರುತ್ತೆ compared of the person, right? So mass ಕಮ್ಮಿ ಇದೆ ಅಂದ್ರೆ inversely proportional, automatically acceleration ಏನಿರಬೇಕು ಜಾಸ್ತಿ ಇರಬೇಕು. So hence acceleration of the football is more. So mass of the player ಏನಿದೆ ನಮಗೆ, mass of the player is more. So mass of the player ಏನಿರುತ್ತೆ ಜಾಸ್ತಿ ಇರುತ್ತೆ. So ಹಂಗಾಗಿ acceleration ಏನಿರಬೇಕು ನಮಗೆ ಕಡಿಮೆ ಇರುತ್ತೆ. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ಇದು ಬ್ಯಾಕ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ತುಂಬಾ ದೂರ ಮೂವ್ ಆಗೋದಿಲ್ಲ, ಬಟ್ ಬಾಲ್ ಏನಾಗುತ್ತೆ ತುಂಬಾ ದೂರ ಮೂವ್ ಆಗುತ್ತೆ, ರೈಟ್? ಸೊ ದಿಸ್ ಇಸ್ here we discussed a is inversely proportional to m, right? So ball moves with a greater acceleration and the leg moves backward with a smaller acceleration. That is again from the Newton's second law of motion, F is equals to ma, and here the applied force is constant. So F force which is applied on the ball is same as that of the force which is applied on the leg. So ಎರಡು ಕೇಸಸ್ ಅಲ್ಲಿ F ಏನಿದೆ ನಮಗೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆ. So from that we can directly write is inversely proportional to m. So if the mass is more, then acceleration is less. If the mass is less, then the acceleration is more, right? So hence acceleration of the football is more than the foot of the player, right? So one more example, if you consider this one as earth, right? So when an object is falling on the earth, right? So an object is falling on the earth attracts this object. That means earth exerts a force on this object, right? So that force we call as F1. So earth exerts the force F1. So idu namge contact force. So idu non-contact force, right? So here the acceleration due to gravity or force due to gravitation is acting. So idu non-contact force ke example, idu contact force ke example, right? So earth exerts a force on this ball to attract towards the center of the earth. So that force we call as taken as F1, right? So in the same way, the ball exerts the same force on the earth, right? It moves towards the up and it moves upwards, right? So that means this is F2, right? So earth ಏನು ಮಾಡ್ತಿದೆ ಈ ಬಾಲ್ ನ ಅಟ್ರಾಕ್ಟ್ ಮಾಡ್ತಿದೆ. That means it acts a force on this ball, right? So example for contact force, and this is the example for non-contact force, right? So if we take few more examples, that is while swimming, right? So while swimming or while walking. So in these examples also we can observe the Newton's third law of motion, right? So while swimming, the swimmer will push the water in the backward direction. So backward direction is pulling the water, means that is the action. So in the same way, water acts the force onto the swimmer and it pushes the swimmer in the forward direction. So swimmer goes moves in the forward direction means that is the reaction, and he pushes the water backward means that is the action, right? So these are the few examples on the law of motion, right? So statement again, mathematically we need to prove for every action there is an equal and opposite reaction. Right? So consider two objects of different masses, right? So calling this one as first object and second object, right? So the first object acts the force or exerts the force on the second object, so we call that one as F1, right? The force exerted by the first object onto the second object. In the same way, from the Newton's third law of motion, the same force is acting by the second object onto the first object, and it is in this direction, that is F2, right? So from this, as the forces are vector, so one is in the downward direction and another one is in the upward direction. So by the sign convention, we can write F2 vector that is equals to F1 vector, right? So downward directionally negative on the counter, upward directionally positive, right? So both the magnitudes are same because the force which is exerted by the first block onto the second block is equals to the force exerted by the second block onto the first block. So from that we can state that is F2 is equals to minus F1, right? So this is mathematical, right? So this we call as action, and F1 we call this one as reaction, or F1 we call as action, or F2 we call as reaction, right? So the magnitude of force that is equals to same. So modulus of F2 is equals to the modulus of F1. That means magnitude of these two forces always remains same, right? So idu ಏನು indicate ಮಾಡುತ್ತೆ ಅಂದ್ರೆ magnitude. So block 1, it adds 10 Newton onto the block 2 means the same 10 Newton is acting onto the block 1, right? So that means 10 Newton is called as the magnitude. So magnitude of these two forces remains same, but the direction of the two forces is always opposite. So one downward direction act ಆಗ್ತಾ ಇದ್ರೆ ಇನ್ನೊಂದು upward direction act ಆಗ್ತಾ ಇದೆ, right? So magnitude remains same but in the opposite direction, right? So here minus indicates what? The direction. So downward ಇತ್ತು ಅಂದ್ರೆ another force upward ಇರುತ್ತೆ, ಅಥವಾ in the forward direction ಅಲ್ಲಿ ಇತ್ತು ಅಂದ್ರೆ the another force will be backward direction. So minus represents what? Opposite to that of the initial force, right? So this is about the Newton's third law of motion. So statement and example. So in the last class we discussed that Newton's second law can explain the Newton's first law of motion and also the Newton's third law of motion, right? So again by taken same example. So first object, second object. So F1 2, F2 1. Right? So that means force exerted on the first object by the second object we taken as F12, and the force exerted by the second object on the first object that is F21, right? So any object having the force, so dp1 by dt is the rate of change of momentum of first body or first object, right? So in the same way dp2 by dt is the rate of change of momentum of second object. So as the body is executing the rate of change of momentum from the Newton's second law of motion, from Newton's second law of motion. Why we are using this means we are going to prove from the Newton's second law of motion, we are going to prove the Newton's third law of motion, right? So from the Newton's second law of motion, F12, that is equals to dp1 by dt. So as momentum is also a vector, right? So in the same way, F21, that is equals to dp2 by dt, right? So now adding these two forces, F12 plus F21, right? So that is equals to dp1 by dt plus dp2 by dt, right? So this we can write d by dt of p1 plus p2. So iduna itara barkobodu, right? So LHS as it remains same, F12 plus F21. So F12 is the force exerted on the first body by the second body. F21 is the force exerted by the first body on the second body, right? Now from Newton's second law of motion, again from the Newton's second law of motion, the rate of change of momentum is equals to 0 when there is no net external force acting on this object. So ಇಲ್ಲಿ ನಾವು ಯಾವುದೇ ತರಹದ extra from the external we are not applying any force. So externally ನಾವು apply ಮಾಡ್ತಿರೋದನ್ನ external force ಅಂತ ಕರೀತಿದೀವಿ, but in this case we are not applying any external force to these two objects. So ಯಾವ direction ಅಲ್ಲೂ ಕೂಡ ನಾವು ಯಾವುದೇ ತರಹದ external force act ಮಾಡ್ತಾ ಇಲ್ಲ, hence the rate of momentum is equals to 0, right? So the rate of momentum is equals to 0 means this term is equals to 0, right? So that is d by dt of p1 plus p2, that is equals to 0, right? So this is when no external force is acting. So in condition ನಾವು ಯಾವಾಗ ನೋಡ್ತಿದೀವಿ, when if any object we are not applying any external force, then the rate of change of momentum is equals to 0, right? So that means the rate of change of momentum on the two objects, so ಈ ಎರಡು object ಮೇಲೆ ನಾವು ಯಾವುದೇ ತರದ external force act ಮಾಡ್ತಾ ಇಲ್ಲ, so hence on these two cases the rate of change of momentum is equals to 0. So this whole terms become 0, then LHS we take this one as equation 1, right? So equation 1 becomes F12 plus F21, that is equals to 0, right? So in term 0 is F12 plus F21, that is equals to 0. Now shifting to the RHS, F12, that is equals to minus F21, right? So this is what Newton's third law of motion. By using Newton's second law of motion, we proved that the F, that is force acting on the first body by the second body, that is equals to the force acting on the second object by the first object, that is F12 is equals to F21, and here we are also getting the minus. So minus getting means the direction is opposite to each other. So that is by the statement equal and opposite. So here also the magnitude of these two forces remains same, but the direction changes. That gives what? That is indicated by the negative symbol. So minus indicates what? The direction is opposite to that of the force F12, right? So hence from out of these three laws, Newton's second law we call as the universal law of motion, that is Newton's law of motion or real law of motion. So in the previous class also we discussed, that is defining Newton's first law by using the second law. Here we define Newton's third law by using second law, right? So by using Newton's third law of motion, right, law of conservation of linear momentum. Conservation of linear momentum, right? So momentum is the product of mass into velocity. So what the states conservation of linear momentum? So that is in an isolated system, linear momentum, or an isolated system, linear momentum remains constant. So this is what the statement of the conservation of linear momentum or law of conservation of linear momentum, right? So in an isolated system means if we consider any one system, so onto that system no external force is acting on that system, so that type of system we call as isolated system, right? So again, from Newton's second law of motion, so from Newton's second law of motion, force is equals to change in momentum, that is dp divided by dt. So as force is also a vector and momentum is also vector, right? So here in an isolated system, the net force acting on any object is zero. That means the force acting on the system is zero, right? So that is F is equals to zero. This is when it is in an isolated system. So isolated system means if we consider any one object, to that object there is no external forces acting on that system, right? So in that case we call that system as isolated system, right? So F is equals to 0, then equation becomes 0 is equals to dp by dt, right? So if we integrate above equation, we get momentum that is equals to constant, right? So this gives what the conservation of linear momentum, right? So momentum is conserved when in an isolated system the net force acting on the system is zero. When the force acting on the zero, then the momentum is conserved, right? So in the same case, if we consider this is an one isolated system, so this system contains many number of objects or bodies or particles. So anything you can consider, right? So if we have up to n number of objects which is present in a system, so this we call as isolated system. So on this system there is no net force acting on this system, then the conservation, from the conservation of linear momentum we can define this one, F is equals to d by dt of P1 plus P2 plus P3. So P1, P2, P3 represents what? Individual linear momentum. P1, P2, P3 because each and every object having a mass and it has some velocity. So this indicates what all the objects having the velocity and it has mass, right? So each object having the momentum, we denote that one as P1 plus P2 plus P3 and up to if it consists of n number of objects, we take that one as Pn. So again, there is no net force acting onto the system, so this force becomes zero. So from or if we integrate this one, we get P1 plus P2 plus P3 and so on up to Pn is equals to constant or remains same. That means this value, all these values will not alter in this system, right? So in the next class we will discuss with the example and we have proof for that conservation of linear momentum. So very important, we will discuss in our next class, right? Thank you.